Okay, so this one's kind of funny. You can do this one two ways. So the first way I'm going to do this is basically how the rest of the exponentials you're going to solve. This is the method you want to use. And then after that, I'll show you something sneaky you could have done. So first thing we want to do is isolate the exponential. Anytime we're trying to solve for x, right, we get as much stuff away from the x as we can. So right here, let's divide both sides by 3. And now that gets me 0.6x equals 5/3. So that says, what do I raise 0.62 to make it come out to 5/3? And for most people, I think that's an I don't know. Like that's not super obvious. And so when it's not something where you can tell, like in those previous problems where you'd have 3 to the x equals 3 to the 2x minus 5, and you just set these equal because it was easy to get these to be the same, that worked great. But now when you can't quite see that, then what do you do? So the answer to that is logarithms. And this is exactly what logs are for, is for solving for exponents. So we're going to log both sides of the equation. And we have been, square rooting both sides, squaring. We've been doing all kinds of things to both sides of an equation. So right now we're just going to log both sides of this. There's that property 3 from the last section where I could take this exponent and bring it down front. So let me do that and get this written a little bit bigger. And then that 5/3, since 5/3 is a repeating fraction, it's going to be 1.6666666 forever. I'm going to leave that as 5/3 so that stays exact for me. If that had been, say, 5/4, then I would have maybe written that more conveniently as 1.25. But be careful not to round things to the last step. So, and this one we're supposed to round to 3 decimal places if that was needed. Right now I have x times a number makes a number, so this log 0.06 is just a number, and so I'm just going to divide it out on both sides. And then you get x equals, this in the calculator divided by this. Be careful when you put that in the calculator to go log parenthesis 5 divided by 3, and make sure you close that parenthesis before you do the division. Otherwise you have this log inside of the argument of that one. Anyhow, if you get that in the calculator properly, that should come out to -1. So when you can't tell like a way to make the bases the same, this is going to be your plan, is you're going to log both sides and then let the logarithms find the exponent for you. On this one, because this came out to a nice pretty -1, what that means is there must have been some clever way up here to do it, so let me show you. Back here when we were at 0.6x equals 5/3, I could have rewritten this 0.6 right here. Let me write it as 6/10 for a second, just because that's, if I see a 0.6, I'm thinking it's 6/10. But then you think about 6/10, and then you're like, oh yeah, that's actually 3/5. Right, so 6/10 reduces down to 3/5. And instead of 5/3, it'd be really cool if this was actually 3/5. So if I want to flip this fraction over, I can do that. But what I have to do, this is right now to the +1. So if I do the reciprocal of the fraction, what I'm doing is I'm rewriting that to the -1. Because 3/5 to the -1 is the same thing as 5/3. There's a property. Actually, let me go back to that thought. So now I have 3/5 raised to the x equals 3/5 to the -1. And there's the exact same -1 I got over here. This is super hard to spot, and in all honesty, I made the video first, did this, and went, oh, it came out -1. Oh, of course it did. There it is. And so then I reshot this so that I could show this piece too. What was it? I think that was all I had to say. I felt like there's, this property right here. This is a very little known property, but it's handy when you need it. If you have a over b to the -x, you can rewrite that as b over a to the +x. So if you have a fraction to a negative, you can flip the fraction and write it as a positive. Likewise, if you have this, you can rewrite it this way, which is what I did right here. because this was 5/3 to the positive 1, and I rewrote it as 3/5 to the negative 1. So that's how I was able to get from here to here. Again, this is hard to spot, so probably this is the best way to go at this. And like I said, this is going to work for all exponential problems of this form you can solve using logarithms. But there's the sneak